All right. Hello, everyone. I'm Alejandro Ranchal from the Consensus Lab team at Protocol Labs. And I'm going to be talking about how to get faster finality in Filecoin. It's going to be rather interactive, so feel free to interrupt. But I'm going to be going over through some options that we looked at, architectural options, and why we chose what we chose, and explain a little bit of the specification of the what we call Granite and the finalizer component. But again, feel free to stop me at some point. So this is the outline. Just very quickly go through a TLDR of how Spec consensus works, in case somebody is that lost. Then some options we looked at for faster finality. Then the option we chose for the architecture. Part of our architecture involves a new consensus protocol that we call Granite. So I will be explaining as well how it works. And just open space for discussion. Okay, so I'm assuming this is fairly already understood by everyone here, but just in case that's not fully understood. So Spec consensus, which is the consensus protocol at Filecoin, is a fork choice rule type of protocol. So it relies on a probabilistic notion of consistency of a block being stable. That is a block being part of the heaviest chain for all members of the, for all participants in the network, and from that moment forever, right? The way these protocols work is they wait for a period of time, call it epochs or number of appended blocks, whatever, after which whatever participant locally considers the probability of that block suffering a reorg in which this block is not part of the heaviest chain anymore is very low. And whatever that probability suffices for him, that's good enough. In the case of Filecoin, there's a particular value that the system itself commits to, which is 900 epochs or 7.5 hours after a block is firstly proposed. And the reason why this is like that is because the state, the power table of the system is part of the state of the system, and it is assumed to be final. So there's a particular value that the system assumes is good enough for the state to be considered final in order to fetch the version of the power table. Needless to say, this is a huge product blocker for many groups in the ecosystem, particularly, I have many examples there. In Consensus Lab, we work a lot at IPC, and it's a huge product blocker for subnets to interact with each other through mainnet. Then we look at multiple options to get faster finality. First, we set up a set of goals, which I list here. Of course, getting faster finality, but that cannot come at the cost of a weaker security model, so it has to be a robust system. We don't want to make strong assumptions, or we don't want to be the cause for strong assumptions in the system. And we also don't want to make significant changes. So the less changes we can make to the existing system, the better, right? We want to follow the path of least resistance. So just in case, just kind of hedging to multiple options, people might be suggesting fork choice protocols. Any fork choice protocol that I know will at least take 10 minutes to finalize any block. So it's just not good enough for fast finality. Some people might be familiar with Avalanche, and it might look very attractive because it provides sub-second finalization. So at first look, looks amazing, but this comes at the cost of less robustness. So only tolerating a 20% adversary and very strong synchronous assumptions. Very attractive as well, what Ethereum is doing, kind of a best effort finality gadget. The good thing about the finality gadget is it involves not much refactoring, so it's kind of an independent module that is just plugged in the Ethereum chain. But the novelty of the architecture they proposed has already come at the cost of many security concerns and many attacks that have been found, and it still relies on strong synchrony. So even in synchrony, many attacks have been found. And in my opinion, that kind of comes from kind of trying to reinvent the wheel a little bit with a very novel architecture. So it doesn't seem like the path of least resistance when it comes to security and some bumps along the way that you can find. And then, of course, the holy grail of distributed systems, BFT protocols, they have the advantage of being fast, being resilient optimal depending on the protocol. But, of course, replacing a longest chain type of blockchain by a BFT-based blockchain will be just too much refactoring. So in the end, we kind of settle for a mix between the last two options. So a BFT protocol at the core of a finality gadget, which is what we call the finalizer component. Yep.
Finality gadget. A finality gadget also in Ethereum, that's BFT.
Ethereum, I would categorize it more of a best effort than a BFT protocol per se. It doesn't have the properties of a BFT protocol in isolation. But I mean, I see where you come from, but I don't think it's relevant to get too much into the details. But just maybe, I mean, this relates with what we're going to say later, and we will go back for that, for the context of Filecoin for the discussion. But yeah.
If you think it's relevant, can you define what a BFT protocol means? Because I feel like I've seen a few different definitions, and I don't know what we mean when we say BFT protocol.
A BFT protocol would be a consensus protocol, so a protocol that satisfies the properties of validity, agreement, and termination, that bases on collecting a quorum of votes. And it should satisfy consensus. So under some adversary, these guarantees are satisfied in a single shot. And then you iterate over that protocol, and that's how you get, instead of a single shot consensus, you get multiple decisions on multiple iterations. Is that understood? Yeah. So yeah, so these are the advantages, of course, of having a finality gadget. And I agree, this is it's not a taxonomy of the state of the art. It's kind of slightly subjective, I guess. Yeah. Okay, so we settled on this thing we call the finalizer component. It's actually a very simple architecture when you treat the consensus protocol as a black box. So we have here the kind of a schematic of how Filecoin works at the moment. So some blocks come from the network, then there's this process that's the sinker that adds them to the local chain structure, and then there's a fork choice rule that selects the heaviest chain out of the local chain structure. So we introduced two components. One is the finalizer, the other one is whatever BFT consensus protocol, and what the finalizer does, it just interacts with the primary chain structure by reading the chain, so really whatever is the head of the chain, that is then given to the consensus protocol as the input, so the proposal, and then the BFT consensus protocol will output a decision of some finalized tip set, and that's the other part of the interaction with the existing chain structure. The finalizer marks that suffix of the chain as final from the previously finalized tip set to the newly finalized tip set. Those two interactions, those two interactions already can be implemented by just using existing functionality in the existing implementation of Filecoin. So reading the head, of course, and then finalizing, marking a tip set as finalized is already given as existing functionality in what is being called as checkpointing a tip set. So we don't need to make changes there. Then the BFT protocol, Granite, needs to be implemented from scratch, but in a completely separated way, so it doesn't have any effect on the existing code base. But of course, it needs to be implemented. And then there are two minor changes that I think I can convince you that are very, very small, and they pay off for the benefit. One is a small change to the block header structure, and the other one is the fork choice rule. That needs to be changed a little bit. So the block header structure, so the problem with with replacing the 900 epoch value by whatever the finalizer sets as final is that in EC, when a validator receives a block, it needs to validate that block, right? And the way it validates that block is it looks at the epoch in the block header of that block, and it subtracts 900 epochs from that epoch, and that's how it fetches the power table used to propose that block in the first place, in order to validate the validity of the proposer, right? But now, we don't know, so a validator receives a block, and he doesn't know what version of the power table was used to propose the block in the first place, because he doesn't know what is the latest finalized tip set that block is aware of, right? Because now it doesn't depend on a static value like the 900 epochs, it depends on whatever the finalizer gave to that block, to that proposer. So we need to explicitly, so we tell the proposer of the block to explicitly state which version of the power table it used to produce the block. Now, this opens an attack vector in which a selfish proposer that wants to maximize profits looks for the best version of the power table for his benefit, so the one that gives him just a ticket to propose a block. And in order to restrict this, we reason about what is a reasonable pointer to a version of the power table. and I'm going to explain that in a minute. The way we call this pointer is the membership pointer. And in order to explain what is a valid membership pointer and what is not, I have 3 examples here. So basically, the proposer of a block needs to refer as membership pointer. It needs to have a membership pointer at least as recent as any of its parents. And the reasoning is, for example, here C2, here at the bottom right, is an invalid block. And the reasoning is C2 refers as a parent block B, which is final. So the blocks in blue are finalized. So that means that C2 could validate block B. That's how it referred. That's why it referred as a parent. So which means that C2 knew that the membership pointer of block B was valid. So C2 knew that membership pointer to block A was valid. Therefore, C2 knew block A was already finalized by the time C2 was created. So it doesn't make sense that C2 will refer to the genesis. He should have reserved at least to block A. Now we have 2 different cases where there's like a leeway for a proposer to select from, which would be these 2 other valid blocks, C0 and C1. The reasoning being that C0 knew that block B was valid, but by the time the proposer created, the block producer produced block C0, block B was not yet final. So we cannot assume that block C0 already knew block B was final by the time it was created. Is that understood? And then in another example, block C1, best case scenario, it was created when block B was already final. Therefore, it already updates the membership pointer to point to the latest finalized tip set. Okay, that's a very small modification, I would argue, but we can debate that. Feel free to interrupt. The other one is even smaller, and it's the yeah.
Sure. Okay. If you mean that, I would like to debate this a little.
Yeah, feel free.
Part of it is, while this is a very small change, we've never actually changed the Filecoin block header structure in the 3 years of Filecoin. Certainly it's doable, but it will be a little painful just from a code perspective. But, yeah. But, so I do have some concerns with that, but if it's necessary, and we'll make it happen. I'm not convinced it's necessary, though. I don't think I fully understood. I guess I'm confused about why we have to associate finality with the look back for the power table. So proposal, don't do any of this and continue to use the 900 epoch look back for power table while still treating finality this way. Does that work?
I mean, you could do that, but there would be an implicit assumption that, so at the moment there's this implicit synchrony assumption that we're comfortable with, which is 900 epochs is a good enough value to assume that there's not going to be a fork that long, right? If you introduce the BFT protocol, you can remove that assumption altogether.
I think my question is mostly why finality and...
Don't touch it.
It's turning itself off. Oh, okay. Thank you. I don't know what I'm doing wrong. Okay, I think I'm mostly wondering why finality and the look back are associated at all. Can I just say that finality is entirely being governed by this, but for my look back, I'm using 900 epochs, and in this case, obviously, that'll always be beyond finality anyway, because our finality is expected to be much more recent. But even if it weren't, does that matter?
It works, but I mean, so you said you're wondering why the 900 epoch, so the look back and the finality are related. Mm-hmm. Well, I mean, they're inherently related, right? The reason why 900 epochs were chosen in the first place for the power table is because the power table is assumed to be final, right?
So also there's another reason, is it significantly simplifies validation of blocks because in one case you know exactly which block you refer to regarding power table. In the other case, you need to show chain of 900 blocks to get to that power table. So for light protocol, light clients and cross-chain things, that's important that you know exactly which power table is used instead of having to walk through 900 blocks.
Yeah, that sounds nice. I guess I'm still not seeing why it's necessary.
I guess, is there any reason we can't just put this in the state tree? Like, why does it have to be in the block header? Like, we can just have an implicit message that you send that adds the state tree every single epoch.
Yeah, it could be in the state tree. Like, it could be, like, if it's committed in the state tree, yeah.
Yeah, because like, I assume you basically, you look at the previous epoch, that points to the power table we want to use this way in the past or something like that, or not necessarily way in the past, but like at finality. And then so then you can basically do n+1 validation, where you just look at previous state tree and then use that to validate the next state tree, use that to validate the next state tree.
Yeah, like essentially you're hiding it under CAD in that case. Like literally block header in theory could be just one hash, right?
I'm not sure I fully understand the implications of not putting this in the block header but putting it in the state tree, but I think they are the same as if you just remove the epoch parameter in the block header and you just keep it as part of the state tree. Yeah. It will be the same implication. So for the ones who know more about the state tree, if they will be comfortable with having the epoch as a field outside a part of the state tree, then they could be comfortable with this. But that makes me slightly uneasy. So I don't know it enough.
The tricky part is syncing and validation. The thing here is, like, my understanding is this data structure that's going to be the power table, which is already large. We put the epoch and everything like that in the state tree because, like, we use that as part. Basically, we put the epoch in the signatures. We put the epoch and signatures in the block header because it means I can very quickly say, like, hey, is this a reasonable block header? And more importantly, I can then dispute. So I actually think that's the important part. The important part is everything that we use in a dispute needs to be in the block header, which also then makes syncing possible because now with syncing, I can know that miners are not just going to make spam block headers because I could dispute those and cost them a bunch of money. Yeah, but this does not need to, as far as I understand, like disputes aren't relevant here, so we should be fine. Unless I'm missing something.
All right. I'll think about it a bit more. I'm a little confused about what does it mean to put a, sorry, what are we proposing putting in the state tree step? This
is a bit of a rabbit hole. I suggest that we move on.
Yeah.
I'm personally not worried about changing the block header. It's just a matter of code. I'm also not convinced it's necessary, but
Okay.
I understand why you want to do it.
Yeah. All right. So we move on then. Yeah. The other change is it's immediate and conceptually inherent. I would say, and yeah, I wouldn't be too worried about it, but just to be fully transparent. So the other change has to do with if we want to make the finalizer component output a prefix to the easy chain, we need to redefine what is the heaviest chain so that there's no divergence, right, between what the finalizer component is finalizing and what is the heaviest easy chain. So the moment the heaviest easy chain is defined as whatever chain is backed by the most power from easy, we need to redefine it into whatever suffix of the heaviest finalized chain is backed by the most power from easy. So an example here would be assume everybody proposed blocks with just one ticket. So in the normal scenario, the heaviest chain will be the one at the bottom, right, the heaviest fork, so ending with the head of D2, but the finalized chain goes all the way to B0. So there are two suffixes of that chain. One is that chain itself, and the other one is that chain with the tips at B0. So that will be the new heaviest finalized chain. Sorry, the heaviest chain, the new heaviest chain. Very small change, very immediate as well, but it needs to be made into the implementation. No questions, okay. Okay, Granite. So I was told yesterday evening that people would like to know a bit more about specification of Granite. It's actually a very simple protocol. I mean, this is not going to be, this is not a conference, academic conference, so there's no point in getting into correctness or anything like that, but just to explain how the protocol works a little bit, so it's a round-based protocol. It's fully leaderless, so there's no roles or anything, everybody executes exactly the same code. And each round has 4 steps that are shown here. They roughly have the same logic. It just consists of broadcasting a message that contains the round number and a preferred value, waiting for some condition, which in most cases is a number of messages. In the first step is also some 2 delta period. And this 2 delta, of course, is, well, anyways, for the ones who know fast synchrony already understand this 2 delta. And it's not worth getting into details. But, so yeah, so every step terminates when somebody has received, it starts when somebody has received enough messages. And yeah, it just consists of broadcasting the same type of message format. Kind of the trick of Granite is message validation. So this is kind of different from other protocols, but it does make it very, very robust, and particularly for Granite, it makes it correct. So a message that is received is ignored until the receiver of the message can justify the proposer having proposed that message in the first place. So what do I mean by that? So for example, if the proposer receives a commit message, so look at the second blue step, not the first sentence. So suppose a process receives a commit message for value 2, for example. So this message is ignored until the receiver receives at least that number of prepared message for the same value. Because the only way a correct participant could have sent a commit for that value in the first place is if he had received that many prepared messages. Otherwise, it doesn't make sense to even consider this as valid. So that really restricts what the adversary can do in the protocol. And in particular, this technique is what allows us to provide censorship resistance against a very strong adversary. And I can get into that later. Is it worth getting, does anybody have any particular question about the consensus protocol?
So guys, feel free to ask, because like we have this unique opportunity, we are in the same room.
Yeah.
So just pound on it if you want.
I got lots of questions. Lots of them are quite detailed. I'd rather you finish the presentation so I can sort of decide which are most important.
That's fine. At the moment, nothing. So I continue. So going back to the goals we had set up at the beginning, particularly for the Granite, for the consensus protocol, already justified the finalizer. So weak assumptions, Granite works in a partially synchronous environment and is resilient optimal in that environment. That means it's safe and live against an adversary control it up to less than 34% of the power table. It's a simple protocol. Again, it's just 4 rounds that repeat, 4 steps that repeat in iterative rounds. Everybody executes exactly the same code, roughly the same logic. It's robust because it's fully leaderless and it doesn't assume synchrony for safety. It's resistant to eclipse attacks. It's resistant to denial of service attacks. And the variation we have done that, I have different slides for that, is also resistant against censorship attacks, which I know CryptoNet Lab is concerned about, against an adversary controlling 66% of the stake, of the power table with high probability. So that's a very efficient censorship resistance mechanism. And for fast finality, Granite can terminate after just changing a linear number of P2P messages of constant size in the size of the participants running the protocol, which we target will be full participation. So at the moment, all the 3,500 storage providers participating. But of course, there is a practical limit to any quorum-based type of protocol. So it might not be now, it might be, I don't know, whenever we or if we have 35,000 or maybe 350,000. So eventually there will be a need for committees. And if you have committees of constant size, then it will be a constant number of P2P messages to generate that decision. And it will only take, in the good case, it should only take 2 or 3 communication steps with some optimizations that we can do. Because of the first step, waiting for 2 delta, then the expected network latency, the expected latency to generate that decision will be this 2 delta, that is a network parameter, a system parameter, plus whatever some factor of the real latency to generate these communication steps and these messages. All of these, because of all of this is subject to testing, right? We have slightly started prototyping it, but we haven't tested it yet. Once we test it, we will know exactly what are the particular latencies, but we believe we can get even sub-epoch finalization, which is amazing because it will even solve, or it will even provide a mitigation against deferred execution. Because if a tip set is finalized before the next epoch even starts, you can already execute it. It's always going to be part of the heaviest chain. All right. So censorship resistance, problem. Yeah, so this kind of originates from Singapore. I was not there, but I was told about some concerns of a minority of a coalition controlling a minorities, particularly 34% of the power table, being able to censor window post from the rest for long enough to essentially get them out of the power table and just take control of the system. And that's a very valid comment. But censorship resistance is something that is impossible to prove because it depends on ensuring fairness in consensus protocols, and that's virtually impossible to solve. It's actually being proven. So it's not about full prevention, it's about like very effective mitigation. And the way we mitigate it is thanks to the message validation. So this is just like the actual more detailed specification of the first step. Yeah.
Can I just jump in on the assumption here? Like this mentions window post, which on the surface, I'm not sure how that's relevant because I assume, so Granite is a BFT protocol. It prefers correctness over security over progress, right? It will halt in the case of a network partition. Yep. While the longest chain protocol prefers progress over, I'm not using the right word.
Over safety, yeah.
Safety. It's the longest chain protocol that window post matters for. If Granite halts, Filecoin must continue and must satisfy window posts, and that chain must continue. And assuming there's not one of the forks that comes out of that, then needs to be finalized in catch-up.
Exactly.
But Granite is not making that worse. Like if there's two forks, and if there's a big fork, one of those sides is dead anyway.
So I think the problem is in this modified fork choice rule, because you switch, like this is true for EC, but once you finalize on Granite, that's the ground truth from now on. So you're like, it doesn't matter what happens on another fork. So the gist of the problem is modulo what's in blue and what Alex will discuss. So the concern, it was actually raised by Nicola, and I agreed this is a concern. So if 34% attacker, so everyone proposals to Granite are fed from EC. So you cannot propose anything that you don't get from EC, right? But the 34% attacker in Granite can just get their own blocks, like whatever they produce in EC, ignore completely the rest, and just keep proposing that. So that may include only their window posts and not those of other SPs. Now, the attack goes as follows. If, assuming 34% can censor Granite, is that whatever the honest two-thirds majority proposes to Granite is basically censored by 34%, and this is never finalized. But these guys still keep proposing their own tipsets from EC, which contain only their window posts, and since the two-thirds majority is honest, they will just finalize that. So what happens is that the tipsets are basically on a very high level, is that only tipsets which contain adversarial window posts are finalized. Therefore, they are the ground truth. So this is the gist of the concern.
Yeah. And that's
if that's clear.
a valid problem.
So it's very so normally the problem here is that we mix EC with Granite. So in BFT protocols, 34.
Yeah, all the complexities are going to come from mixing. Changes the
so 34% adversary can halt Granite. That's fine, and you will not find a BFT protocol that doesn't rely on synchrony, which doesn't have this assumption. The problem is this power leakage, which links back to window posts and the particularity of Filecoin. Like, if you apply similar thing to Ethereum, you're not going to get the same problem because you don't have the power leakage. Because the Ethereum doesn't slash inactivity, let's put it this way, of validators. It just slashes equivocation. But since we slash, essentially, by if you don't post a window post, we are going to slash you. So we are slashing inactivity. Therefore, censorship attack turn into power leakage attacks, and there is the concern. So just that we are on the same page, and now we can discuss.
Can I follow up on that? Like, does this mean that Granite, if I'm in the honest majority, will I finalize a tip set that's on a fork that I see as lower weight?
Yeah, if that is what comes out of Granite, then that's what's finalized. Yeah.
Yeah, but like let's say we have a fork, right? We have a
just a Granite, right? Just a Granite, and you propose, of course, whatever you think is the best candidate to finalize now, which is with the head of your heaviest chain.
Yeah.
And
the majority also is on that heavier chain, but we have a adversarial weaker chain with 34% power that censors other window posts, which reduces its weight. So we have two forks. One is the heavier fork with
by the majority,
honest, and we have will the people on the honest majority fork finalize the other fork with?
Yeah. So before Singapore, the answer would have been yes, but with a small modification we have made it to the protocol. Now the answer is no. The finalized version would be the one by the honest majority.
I'm jumping ahead of the wagon a bit, but just like Ayush said, and we did not collude before, this is very simply solvable if you just don't try this power table trick and replacing EC, but just look at it optimistically and keep the 900 epoch for the power table. And do not just count on that as replacing EC, even if you think about it eventually.
So,
and it will solve so much of the complications here.
yeah, but I mean, so you need, if you don't make any modifications to EC resulting from the output of Granite, what you might get.
You have to do that, just the checkpoint. That you can only consider that. You have to do that, but not more than that.
I
Yes.
think you still have this problem, though.
Yeah, exactly.
Even
If
if
you
it's
check when you have
900
that
epochs
problem
before,
already.
it's delayed, but I think the attack that's on the slide is...
But practically, it happens after 900 epochs. You have 7.5 hours to realize, shit, something's happening, I'm being under attacked. I need to take some steps.
Yeah, I think we are getting rid of 900. Like in this world, there is no 900.
So what I'm saying, there
Yeah.
should be.
Why?
Because
But
if we're looking at the power table, you don't need to have this, you can keep looking at, okay, I'm looking 900 epochs did of past. Why do I need to look at the last finalized?
Yeah, but that doesn't solve the
Power
problem.
But I'm not sure this solves. Why this will solve the problem?
It just delays the execution, so the actual
It
execution
means
of the
that
problem.
the problem only arises if you manage to keep this attack and not to finalize anything with Granite for the duration of 900 epochs.
No, actually, no. The only thing you need to do is to finalize with Granite, so that Granite terminates, but it terminates with the preferred value of the adversarial
Yes.
collision. So it
just
only has
keep-
to happen
keep-
for 60
keeps
epochs.
finalizing 1 or 2 blocks, like to simplify, it keeps finalizing 1, 2 blocks per tip set, and it just keeps doing that. Because this is what the 34% adversary most of the time has. And it just outputs this, like, and of course you can apply what you are looking into, like, is this a rich data structure or not, but that's complicating the protocol even further. So we are trying, like, so modular composition I think modular composition gets to power leak, and we are trying to fix it. Do you want to now? I think it's
The
vital.
fix? Yeah.
I think it's vital to dive into the fix.
Yep, let's do it. So before...
Because I personally am still not buying the fix because I didn't understand it. So
Okay,
yeah.
so before Singapore, we did not have what is in blue. So we just waited for 2 delta, and then in the converge step, so in the first step of the Granite protocol, we just waited for 2 delta locally, and then we selected one of the values out of all the values we might have received during this 2 delta, which might have been nothing, which meant that in the case for the context of message validation, for the proposed step, everything will be valid, because we have no idea what anybody could have received during the converge step, during the first step. But now we enforce that if anybody who terminates the converge step, so anybody who sends a proposed message, has received some gamma of converged messages. So we know they have received some messages from other processes. And then there is a deterministic function that is defined as a system parameter that we call select, that defines which of the values in any converged message received should be selected. And this is very abstract, but let's get into the particular definition of the select function. So the gamma could be n minus f, so 67% or 67 messages, assuming everybody has 1%. And select will be select will select the converged message that proposes a tip set that contains the most window post. So then when you validate a proposed message from the second step, so you receive a proposed message with a value, what you do to validate that proposed message received is you ask yourself, could this sender of the proposed message be correct and have included this value? And that means, is there any subset of n minus f converged messages such that applying select, the function select, to that subset gives this value? So if there is a coalition between the 66 correct and the 34 adversarial that propose different values, and the 34% are trying to censor, they will include less window post, and that will never be a valid value to propose in the proposed
I
message.
think this solves the problem that we discussed in the previous slide. I'm afraid that it might introduce, like, if I'm a Byzantine guy, I'm just sending to few people very fat tipset, 5 blocks, but I'm sending to others something else. And if no one else, like, it increases my chances of, like, yeah. Do you have a proof of this? Like, it solves, I agree, it solves the power leakage problem.
Okay.
That I give you.
So what do you
that's
think
good.
is a worry then? That somebody will do what?
Proof of termination of this protocol with any adversary controlling less than up to 33%. This is what I would like to see.
So you want a formal proof of that? Well, we haven't had the cycles
yeah.
to get into that level of formality, but I'm definitely not concerned that this changes the correctness of the protocol in any way. Because the validity of a proposed message is not about, there's no one ground truth. The only question is, does it make sense? So if you are correct, your proposed message will always be valid.
Yeah.
So it doesn't change anything when it comes to termination or safety.
This coupling is terrible to me. I don't know what the problem is with it, but it's going to be a really subtle problem that's hard to find. I don't know whether it's going to affect the correctness of EC or the correctness of Granite, but one of them is bound to have a problem.
So in BFT protocols, this style of protocol is called external validity protocol, because the validity, so what they are doing here is they're saying, I will not accept any proposal to Granite. I will accept a proposal that has certain features. And features come from external world. And that's pretty common. If you model it that way, that's pretty common. And here they come, well, we are coupling with EC, this protocol. So these features come from EC. And that's not bad on its own, right? So it's just, this doesn't worry me too much, right? Because we are still feeding, like the input to Granite is the output from EC. So we need some information about characterizing the output from EC in order to prevent the power leakage attacks. And this can be captured in a function. Like the function could say, yes, I'm taking the most tipsets, and then since you're expecting 5, you shouldn't be finalizing something that has 2, because the attack actually does that. It finalizes tipsets of which has up to 2 blocks, like 1.5 on average, or what's 34% of 5,
Exactly.
right?
Yeah.
That's fine-ish.
Yeah.
You go.
If I saw a coupling like this, my instinct is to like rewind further, like go back further and start again to not have to end up in this place.
So there is, like, the leakage attack has nothing to do with Granite when you zoom in the box. It really has to do with BFT protocol, like modular composition of a BFT protocol. You can take your favorite, you can take hot stuff, you can take whatever you heard here, you don't have to take Granite. If you modularly compose, what happens in a particular case of Filecoin is power leakage.
Yeah, I sort of get that. I think we have to think more about that problem at that abstract level first.
So another question that the people working at Granite came up with when this became an issue in Singapore is we don't even know what is the censorship resistance of EC. Like, there's no numbers for that. So we're sort of upholding Granite to a level of security that EC doesn't have in the first place. But even if you uphold it to that level of security, we have this variation that, at least for that, definitely doesn't change the safety or liveness of Granite, solves the problem, and I would argue it doesn't change pretty much anything in EC either.
Yeah, I don't think we can do this, unfortunately. It's too much. It's just not clean, and it's gonna introduce some problem somewhere. I don't think I think I need to. Sorry, I'm a little slow today. But I think I'm hoping that if we look at the Granite protocol itself, essentially that core algorithm, we can solve this some other way. I do think the problem is real, and so a solution is needed. I don't think this should be the solution. So I think further thought is needed here.
Yeah, so again, any partially synchronous consensus protocol will suffer from this problem. And a solution will have to look like this, will have to be coupled with EC. Otherwise, this.
It can be coupled with EC, but here you're coupling it with messages that are landing on chain. Right? Because you're saying, oh, is the VTIP set the one with no window post submitted?
It's coupling with like deep semantics inside Filecoin's state execution. It's just like it's too deep.
So do you have a more specific concern because it doesn't change anything in terms of safety or liveness? So I mean, I get that they're coupling the deep semantics outside of the blockchain, like structure, but what's the actual concern? Because a correct behaving correct will still, it wouldn't change anything for him. All his messages will be valid.
This isn't a clear concern, but we don't do anything like this anywhere in Filecoin today. And yeah, it's at like the consensus layer of like which block do I want to be finalizing is just very, very far away from the window post message that has to be submitted every 30 minutes. Obviously, that's what leads to the power that ultimately powers the network and so on. But I think separation of domains is needed here, and this is I think this is too connected.
Yeah. I can't express exactly what's wrong with it, but all the engineers' spidey sense for like, this is bad, just went off. We don't have to solve it now. We probably can't figure it out right now. Let's keep going and follow up.
That's a valid concern, yeah. So I guess we are proposing this to be a preferred tip set if you see a bunch of them, but let's take it from there, right?
So then also for the spidey sense of the core devs, how much of a concern is a 34% adversary censoring? And what do you think is the value currently in AC?
Oh, I have no idea. I'm not a consensus researcher.
So long as we are aware of this, so we need to put this forward, and Nicola's observation was amazing. Like, if we agree on modular and we agree that 34% can censor and power leak and we deem this improbable, and community says this and it's all in public, whatever, So this could be a road to solution, but it has the coupling.
I have one question around the censorship of EC. Right? When you say censorship, because like EC is the longest chain protocol, which means that censoring it would mean censoring the broadcast layer.
No, you really just need to censor whatever becomes the heaviest chain in the end. A window post that's not part of the heavier chain, it doesn't matter.
But we rely on the broadcast layer in order to get the heaviest chain, which means that as long as the broadcast layer is protected against certain attacks, censoring gossip sub is hard.
No, but you don't need to censor gossip sub. You just need, if you control 33% of the power table, you use inherent discrepancies, also existing forks, in order to favor the fork that doesn't include particular window posts.
Right, but then that's independent of the underlying consensus.
But there are consensus protocols that can provide more effective mitigations against that.
So I'm coming back to this is a problem that currently exists.
It will never be solved. It cannot be. I started with that. There's no formal proof. It cannot be solved. It can be mitigated. Yeah.
But do we want to mitigate it?
That's the question. So this is a solution for mitigation.
This is a problem. So what I was trying to understand is this is a problem that currently exists.
Exactly. Yeah.
Okay.
And we don't even know the number. It might actually be lower than 34%.
Okay.
Yeah. Yeah.
Again, about this leakage, I don't think it's it's because of the coupling it has to be. I think if we simplify it, to look at it in a simpler, the optimistic way, don't have it, because let's say we're saying we're finalizing every module 10, okay? That is what we want to finalize. And in your consensus protocol, the BFT protocol, you're saying, okay, I only give you a decision, not null, if there is more than 50% support from it from the beginning. Done, you don't have it anymore. So it's because we are trying to replace EC with a BFT.
No,
even though we're not saying it, we are trying to do it, and then we're getting stuck into problems.
But this problem exists in EC.
That is my opinion.
The problem exists in EC, though.
Let's unblock. I think we are, yeah.
My instinct is that the censorship in EC is much harder.
Yeah, I have the same instinct. I don't have, I didn't work on an EC consensus back when it was being designed, but we can ask some people around.
Again, if we have a FIP and FIP discussion discussing this and it passes and we are fine with modular, fine. But,
Sure.
yeah.
Right.
We just need to have all information so we can make an informed decision. So.
Yeah, and again, this is just that there might be, so I just think this is, I understand the concern because it changes kind of like the preferred tip set to finalize by something that currently is not the criteria to prefer a tip set to finalize. There might be some other definitions of a select function that couple them better and provide still quite effective mitigation strategies.
So Alex, I would say just when you write the FIP, make sure this is like part of the of some section.
Yeah, I think this particular proposal is maybe a deal breaker, but the existence of this problem is not a deal breaker for Granite. Potentially because we can solve it differently, or potentially because we say actually we're okay with 34%. So we can definitely, I think, we'll think about this more, but this is. If there's more, we can go on.
Yeah, I'm not super okay with 34%, but now that I understand the problem better, I'd like to go back and spend some time thinking about it high level. In EC itself, I don't think it's the case that 34% can then stop the window posts from the remaining 2/3. I think those 2/3 are going to fork. Nothing can prevent them making progress. They'll eventually end up with more. The problem here is that the 33% can stop the 66% making progress. They can leak the majority of the power out of the network. I don't think you can do that in EC.
There's definitely a probability with which the 34% attacker can do that and
Probability.
be undetectable.
You will fork, right?
Yeah, but what matters is so there's a probability that the 30,
But you won't affect liveness, right? Because like the 66%.
But liveness is not the issue here.
Here the problem is, so EC alone would continue and it would be the heaviest chain, but you're changing the heaviest chain to the finalized chain and then there basically Granite takes over.
Yeah, but let's take a very extreme example. It will be a very small probability, but you will understand what I mean. If there is 5 proposers per epoch, there's a probability that in 60 epochs, the 5 proposers of the 60 epochs are by this 34%. And in that case, they can censor.
Do we have a discussion?
Easy as that.
Do we have a discussion about synchronous alternative? Maybe we should unblock
We
it.
do have it.
Okay,
yeah.
so let's go to that.
Okay, yeah, right now. All right, so yeah, there are trade-offs, and this relates to what we're talking about. What are we worried about, right? Are we worried about a 34 or to 49% adversary, preventing safety, termination, maybe censoring particular tip sets? Or are we worried about some small adversary that also takes advantage of some network disruption that lasts for some period of time, doing the same things, preventing safety, for example, or censoring as well, with some probability? Are we also worried, is it also desirable to just have a trade-off between an assumed latency that we assume that should never be broken for safety and like fast finality? Because of course, that's an inherent trade-off if we start using latency for safety. We're gonna want a very high latency assumption to ensure safety, but we want fast finality as well. So I gathered kind of 3 options, of which I can tell you that the 3 people working at Granite prefer the one I proposed before, so the partially synchronous Granite. So one is kind of like this best effort, kind of like Ethereum kind of thing, that if Granite doesn't terminate for whatever reason, it doesn't solve censorship, or censorship can be solved in a different way, but if Granite doesn't terminate, so if there's no liveness, then there's some like very, very high value synchrony assumption after which you just kill Granite and restart. The other one is embedding synchrony in Granite. So it's kind of a synchronous protocol, basically, that tolerates a 50% adversary, in which you have this trade-off between latency and safety. So you want low latency for fast finality, but high latency for safety. And here's like kind of the comparison of what each of them ensure. And again, I'm calling it Granite, but you can replace it by synchrony, any synchronous protocol, and you can replace this by any partially synchronous protocol, and you can replace this by, I don't know, Ethereum finality gadget. So I would definitely not go this way, because of that column, the fact that it creates a dependency between latency and safety. And it's just a pain point. If we want fast finality, and also safety, this is just gonna be, it's just not gonna work, I think. Then this one is fine. It does remove safety when the adversary controls the network, but you can set a very, very, very high value for the synchrony assumption because it's not dependent on how fast a value is output by the protocol. But this is inherent. There's just no, and it's not like EC is better. It's just EC will fall under some mix of this, like any other consensus protocol. So these are the three options.
I haven't ingested this full protocol, this full table yet, but I think taking the goal of fast finality too seriously might be slightly too narrow a focus. I would say the goal is we want fast finality when we can have it safely. Otherwise, we want safety.
Yeah.
So I don't like that red cross in the bottom right-hand corner. That's like not the goal to me.
In which corner? Here?
That one.
Yeah, no, that's definitely not. That doesn't worry you, you mean?
That has to be a green. Wait. No. Sorry, that doesn't bother me. I don't care about that. No.
You don't like this one?
Yeah, I don't like any of the red crosses under safety. Wait, what? I don't understand what these labels stand for. So that's that's a start.
So basically, for example, EC will be something like, I guess in terms of safety, it will be something like the middle row. So it doesn't have. Well, no, actually, it will be something more like the bottom. So,
yeah. So just looking at the first column, the bottom row is the only acceptable row in the first column.
But what about the fourth column?
I don't understand what that means, the column heading.
So, yeah.
Legend is important. So the first column is only relevant if you want to protect from 34 to 49% adversary. Otherwise, like up to 33% safety is there, regardless of the adversary controlling the network. But then this should be split basically in the network control. So the Granite as proposed on the previous slide is resilient against the adversary partitioning the correct nodes.
You're saying the adversary gets to choose a network partition and then be the one node in the middle that can lie to both sides.
So it's a really powerful network adversary, which honestly is debatable. Like, can you have an adversary on 3,500 Filecoin SPs to partition them to its will, right? And if you think that that's not a realistic adversary, then we might want to look at synchronous options, because they allow us to have more greens in 34 to 49% domain.
Right.
Yes.
Yes, but then you introduce this dependency between, which that's a valid point. Maybe
I don't mind that they're dependent.
What is?
I don't mind that we lose low latency.
Right.
Sometimes.
It wouldn't be sometimes. That's the thing. This is an assumption that you need to make for all cases, because if it breaks once, safety is at risk. So it's a direct conflicting trade-off. That's what this column stands for. So you need to find a value. So in this is 900 epochs, right? So you need to find some other value. It might not be ours, but still, it should be a value that we are confident that it will never be broken by an adversary.
Yeah,
Exactly.
Yeah,
Alex, I'll try to explain. It might be confusing because you see safety and you see an X, but it's a very specific definition of safety. It means, for example, it will be broken only if for 900 epochs you had a very strong partition.
The 900 epochs has to go. Like, I don't agree with Ayushi that 900 epochs can't be part of this.
So,
proposal.
but you can put it as 1 day. Okay, only for 1 day.
No,
Nothing.
just hold. Just wait until you can do it safely.
Okay, but we hear you.
But-
We hear you.
Just a side note, 1 day will even be more than 900
Sorry,
epochs.
I just want to clarify something here regarding the possible choice of a synchronous protocol. Is that adopting a synchronous model does allow you to tolerate 49% adversary. but it opens the door to other, very dangerous attacks. I think it's common to say that, like the adversary needs to have the power to create a partition in a network, but it doesn't need to have the power to partition the whole network. Like the adversary can cause a safety violation if it can partition a single node from the network. And this makes certain targets very vulnerable and very, appetizing to economically incentivized adversary. You can think of a node from an exchange or from a commonly, used node in the network by other clients. And if somehow an adversary can isolate that node from the network in a synchronous setting, it can cause a safety violation. And I think this will result in a very brittle network in general if we allow this to happen.
Yeah, and that's something that already happens in EC. So if somebody's isolated for 900 epochs, it's madness for that person.
When
900 epochs might be a very high value, and that's why maybe we're mostly comfortable with it, but we want fast finality.
So way back on your first slide, there was a thing about goals. A goal that wasn't there that I think should be there is that this consensus mechanism is useful for interop between blockchains, which means this consensus can be validated inside a smart contract, inside another blockchain, which is not quite there yet, and that's one reason why the 900 epochs has to go. Right, and once something gets committed into another blockchain, it's unrevertible. Once a smart contract in another blockchain accepts something as final, there's uncountable economic damage that can be done if at that point it forks, right? The Ethereum's view of Filecoin forks from Filecoin if that goes back. So we want to get to a point where that can't happen unless a majority of the Filecoin network have signed a message saying this is final.
Yeah. So this kind of problem of bridging depends on what we do with this, but I would say it's in a way kind of an orthogonal problem. And we have decided to focus specifically first on getting a protocol that enables that, but gives fast finality first, and then in a different FIP and a different project, focus on that in particular, just because otherwise it will be just too much to discuss at once, too much for a FIP. But there's no fundamental reason why any of these solutions will not provide that level of security for bridging. And it doesn't, so it could be directly the output of this protocol, or it could be this protocol complemented with some extra procedure.
Yeah, but what I said requires a green tick in the left column.
Yeah, but you could always, but it's in a different table. It's not for the same, so this is for Filecoin itself, but then you could have a complement, so some extra feature that ensures this at the cost maybe of no liveness, which is completely reasonable when you're bridging, right? So it's just a different problem, which can use what we're doing here.
Alex, I have a question about in the abort Granite, which that's my favorite. But why do you have the safety on the left column and X? You can put the V there and the X on the liveness.
Also,
and that would be, I think that is the point in an abort Granite, that you put it safe, maybe not for 49, but safe for more than 33.
That's Granite. That's abort Granite assumes synchrony for safety. So
no.
How do you so you terminate when
no,
you get
just
a quorum?
Don't. That's the point. You don't.
So then you terminate when you get a quorum of 2/3, like a classical passive synchronous protocol.
Yeah.
In that case, it's not safe if the adversary controls 34%.
No, you just return null, for example, but you need more in order to make a decision. Or you can destroy the liveness. That is what I mean. You don't have to terminate. You can, instead of liveness, have better safety, but no liveness.
So how will you modify the protocol? So you get a decision from the protocol, because you get a strong quorum.
No, you don't get. You get a decision, for example, if 80% of the voters vote in favor.
Right, so you will just increase the threshold.
Yes. And
At the
then
cost of
there will
safety.
be a lot of times that I will not have liveness, but I will still have safety.
No, wait, you should decrease the threshold then. 80% will provide more safety than liveness. You should have like 50%.
That is what I'm
So how do you
aiming
have
to.
safety?
So I'm going to keep safety.
You're
but
going to
it's
keep
gonna-
safety, not
But
liveness.
it's going to cost me in liveness.
Yeah, you could do that, yeah.
I'm not
you could do that.
Also, X in that doesn't account for your fix for external validity coupling with EC.
It
So
does?
strictly speaking, no, the top left. This is not X in case of,
Well, for safety,
yeah.
so the
You need
variation
network.
of-
You need network there. So you would need another column. This is not a great table, by the way. So because 3449 without the control of the network wouldn't give you X with external validity fix. You would need network to give network control to the adversary plus 34% in order to have a partitioning attack.
I wouldn't call it control of the network.
Well, that's a partitioning attack is control of the network. Because you said plus network there.
But there is no waiting period in the protocol embedded. So, I mean, control of the network would be just being faster than the rest. You don't need to control, you don't need to delay anybody. You just need to be faster. So it can get down to just luckiness, to just luck.
But probabilities don't work like on 3,500 node population, they don't work that way. So you would really need to control.
But yeah, you're
the
right.
network, but-
It's control the network.
Technical point, we have 5
Yeah,
more
it will be
minutes.
control the, yeah, actually, yeah, control the network will be
So we
more,
need, I think this table is a bit, it's a bit all over the place, but like we need to kind of,
But the point I'm trying to make with network here is that even if the adversary controls the network, so the partially synchronous protocol doesn't suffer from that. But yes, you're right that I should have agreed on network in both sides.
Can I ask some other questions, which you won't necessarily have time to answer, but just to like, so that the questions are out there. So not in the slides, but in the paper, of which I've read 10 pages, the protocol is expressed in terms of n integer number of nodes, each with an equal vote. We don't have nodes with equal votes, we have a power table. How is that mapped? What's the plan for?
Yeah, no problem about that. That was just a simplicity. We do have some sections at the end of the paper where we discuss how that is changed. Yeah, that's not an issue.
it's weighted, you weight every vote by the weight in the power table. But you need a sample, like you need a snapshot of the power table to match.
Yeah.
Yeah, totally agree, you
voting?
need to snapshot
Yeah,
of the
yeah.
power table, and that's.
But otherwise it's totally, so your power is twice as mine, your vote counts twice as
Yeah, okay, but in the first stage, in the converge stage, it's just min ticket, and every participant has equal chance at the min ticket. So does that mean that sibling a whole lot of small miners will get a preference for
You'll get
submitting
twice the
min
chance
ticket?
of a ticket.
Sorry?
You get twice more, if your power is twice my power, you get twice more the chance.
Okay, I just need to read more, and that'll be
Yeah,
resolved.
it's really weighted. So we typically make, but like whenever we do this, we do it with equal votes, but actually transformation to weighted consensus is one of the simpler ones. So that's.
But we
that's
do
not a
explicitly
concern.
discuss it in some sections at the end. Yeah. But what you said is a very valid point. How much the adversary needs to control the network is not as much as in the synchronous protocols, but there still needs to be some control of the network for the
I
attack to
would
take
be
place.
inclined, so of course I totally respect and Alex and Ayush and others are like ones that should have more of a, like their vote on this should have more weight than mine. I could live with a coupling on external validity, but then again, it's a live system, so we should spend more time on that.
Yeah, of course, there's a very clear preference for the people working at Granite, which is just the top row. And again, very important remark by Marco that these 3 columns implies plus network as well, so the adversary needs to have some control of the network in order to exploit partitions that should already be there.
Not for liveness though, but like it's really.
Not for liveness.
It's really, yeah.
So yeah, so that the preference of Enrique, Matei, and I will be Granite with the modification for censorship resistance that we have suggested. But there could be other modifications that provide some level of censorship resistance. It could be that that's not a bigger issue, or it could be that the preference of the community is some of the other options. But you will not find asynchronous, you will not find any consensus protocol that provides some faster finality than fork choice rule protocols that doesn't have to pick between one of these. It's just inherent. These are the three options that are out there, with some variations that we have discussed.
So given, like, maybe we should spend 5 to 10 minutes on how do we proceed? Is it FIP discussion, FIP, like, because like we want to move this fast, but not faster than we should, but not slower than what's possible, because we need to get it done, right?
Yeah, I mean, it's a very complex thing. There's both like Granite on its own as a BFT protocol, and then the choice of Granite as the BFT protocol to use, and then the way of integrating a BFT protocol with Filecoin are sort of three different things that form the big picture about how do we get this fast finality and verifiable, like, well, how do we get any finality, right? We don't have finality. How do we get any finality and then as fast as possible? So it's hard. I do find while I've read the FIP discussion post, it's very hard for me to like write a response. I've got to spend hours thinking about it, and it's much easier for me to like read the paper and like put red ink all over it as I'm going with all these questions I've got, and over time I can turn that into like a 4-page response with a bunch of things that need clarifying, and other people can do the same thing. But a linear discussion forum is a difficult venue to make that move quickly. So maybe there's a better way of doing it. This has been a great start, but perhaps more collaboratively editable things might be a better way. If this was in we could make a giant mess of a HackMD or a Google Doc or something.
Yeah, would you be comfortable? We are at the moment working with Google Docs. We're finalizing the FIP draft, the actual FIP, and all these details are going to be there. We expect to have it finished by next week. We could put it
I
on
think it's
GitHub.
very premature to write a FIP here. I think there are many decisions that need discussion first.
Yeah. So what I was going to suggest is maybe you'll be comfortable with, at some point next week, just inviting you to the FIP draft at Google Docs and just collaboratively discuss there directly.
I think we might need a little bit more back and forth, and this might be should we have, I don't know, weekly things on this in which we talk through, so everyone kind of does their homework and then talks through new questions if they have, things they don't understand, and so on. Time zones will always be a little tricky, but it might be what we need to do.
Alex, are you fine with that?
Yeah.
Shall we get, who else should be on the call? Kuba?
Should we,
okay.
Enrique, do you have anything to say about this?
Let's prioritize this, because honestly, like for our IPC, unless this is in, like we are doomed. Honestly. So,
can we set up a weekly call?
Unless we have your solution as well.
Hash this out?
Yeah.
Sorry, repeat, Enrique?
I was asking if you can set up a weekly call to hash these details out.
Because IPC doesn't work with 900 epoch, finally. But this is why we have your work as a backup, but like, we need to flesh that out as well.
I think this is much more important than what I'm doing, but because it is more important, it is very dangerous to rush it.
I'm not rushing it. I hope I position it well. So let's just have weekly meetings and let's make progress on this rather than delay it indefinitely.
Yeah.
This was great. I think we are on the same page.
Yeah, I mean, the cards are on the table.
Yeah.
This is very important for Filecoin.
Yeah.
It is, yeah. It should be done carefully, it should be done properly, it should be done one-off without going back and fixing the stuff.
Yeah.
But it should be done. We agree it should be done. Yeah.
And just Enrique, I didn't get what you said about a weekly meeting. All right, cool. Yeah.
I was just saying that we should have a weekly call.
Yeah.
That's it.
Sounds good. Yeah, so who would like to be in that weekly call?
And I think at this level of detail, we need to have synchronous discussions. Otherwise, we're not going to make much progress if we keep just commenting.
And doing homework asynchronously before that, yeah. So Alex, Kuba, Ayush, Granite team, I will be in. Alfonso, I don't know if you want, but like, let's make few people optional, and then, you know, let's advertise it also at the core devs Slack channel, so if somebody else wants to join. Yeah.
All right, thank you.
Thank you.